Hello, everybody. Welcome to today's lecture. So today we're going to start talking about Chapter 2. Just like in Chapter 1, there's going to be things that we're going to be skipping, okay? But we're going to touch a lot more in Chapter 2 than we did in Chapter 1. It's actually a pretty decently sized chapter, but you can see on the side here, we're going to look at 2.3, 2.5, 2.6, 2.7, okay? So this is where we're going to really start diving into some more math, and this is, more broadly, this is the chapter that covers descriptive statistics. So we're not going to be making any conclusions about the data yet. We're merely going to be describing the data. Okay. So 2.3 in particular is called measures of the location of the data. So you have all of this data, right? You want to know generally where is your data located. So for example, if you have like a bunch of test scores, right, where you get a percentage between 0 and 100, there's going to be way more scores close to 100 than 0 typically, right? Because anywhere below 60 is typically failing, and usually most people don't fail the exam. If all is going well. So you're going to have scores way more scores closer to 100 than to 0. So we want to take that kind of idea and make it precise. Okay, how do we do the math so that we can determine where is our data located typically? So maybe we want to know where the center of our data is. That's what we're going to talk about in, I think it's in 2.5. Maybe we want to know how far apart our data is. That's going to be the subject of 2.7. In this chapter, we're going to look a little more generally, like how do we split up the data into what's called a percentile. Okay, and we're also going to look at the center a little bit and the variability a little bit, but we'll dive deeper into those in the later sections. So measures of the location of the data. Whoops. So what we first want to do is define what's called a percentile. Okay. So the book uses the letter K, the kth percentile. So K could be any number, right? K could be like the 25th percentile or the 90th percentile or something like that. What percentile means is the point at which K% of the data is at or below this point. So it's the point at which K% of the data is at or below this point. So if you had the 25th percentile, then what you're saying is that 25% of your data is at or below this point. So for example, if on a test, the let's say a 70% on the exam was the 50th percentile, that would tell us that 50% of people scored at 70% or lower. Okay. If a 90 was, say, the 98th percentile, then that would say 98% of people scored at 90 or lower. Okay. A good example of this, the first one that springs to my mind is standardized testing. Okay, typically when you take a standardized test, you are told how you did as a percentile. And then typically that'll translate into like a number or something. So for example, on the ACT, the SAT is the exact same way, it just uses different numbers. On the ACT, you get a score between 1 and 36, right? So the ACT gives a score between 1 and 36. Okay. So the 36, this is the score that you get if you're at the 99th percentile. So this means that if you got a 36, you did better than 99% of people. So that means that you got more questions correct than, or the same amount as 99% of people, right? And this is like rounded down. It could be like more like, even if you're at 99.9%, you would still get a 36. If you were the highest scoring person of anybody, if you got like every single question right or whatever, you'd still get a 36. So really, more accurately, this would probably be like the 99th to 100th percentile. But there's only technically one person who could be in the 100th percentile. There's only one person, unless there's a tie, there's only one, or maybe at least a few people who did better than everybody, right? So more generally, it's just the 99th percentile. They don't typically define the 100th percentile. A 30, for example, is the 95th percentile. Okay. So if you got a 30 on the exam, that means that you did better or the same as 95% of people, right? So these are all still great scores. And you can see like the differences between 30, 31, 32, 33, 34, 35, 36, they're not that extreme, right? There's not that many people up there in the first place. Even if you got a 30, you might think 30 is significantly lower than 36, but it's only a 4 percentile difference, right? So even at 30, you're still doing better than 95% of people. So where's the halfway point? Okay, the scores are between 1 and 36. So naturally we think, okay, 18 is probably the 50th percentile, but that's not actually the case. I have them pulled up here. 18 is the 36th percentile. Okay. And this is according to the most recent data, of course. I think it can change year to year. But 18 is actually the 36th percentile. So if you get an 18 on the exam, that means that you're doing better or the same as 36% of people. Okay, so it's not actually the halfway point. The halfway point, it's kind of skewed towards the top so that more people are getting higher scores. So what is the halfway point? Well, there's not an exact one, but 20 is the closest. 20 is the 49th percentile. Okay. And then 21 is the 56th percentile. So if you got a 50, you'd probably, they would round it either to a 20 or 21. I don't know exactly how they make that determination. But so if you get a 20, that means you did better or the same as about 49% of people. Okay, so almost half. Where is the 75% mark? Again, it's not exact, but 24 is the 74th percentile. Okay. So this might be surprising. Look at the difference between 20 and 24. There's a 25 percentile gap here, right? And you're only going up 4 points. Whereas with 30 to 36, there's a 6 percentile, or there's 6 numbers, but there's only a 4 percentile gap. So this is definitely not like evenly distributed, right? In fact, if you were to look at it, it would look like a bell curve where most of the people, this would be the score of 20, and then most people would be concentrated here, and very few people would be in the tail here. And this is what we call the normal distribution, which we'll look at in a later chapter. I think it might be chapter 6. I can't remember the exact number. But so the ACT scores, they're quite different than what your intuition might say, right? Where is the 25th percentile? Um, the closest one is 16. Okay, so 16 is the 23rd percentile. And now what's even more surprising, 11 is the first percentile. Okay, so if you get an 11, that means that you've only done the same or better than 1% of people, which is this is as low as it goes. It doesn't actually, I don't know if they give scores. I think they do give scores lower than this, but at that point they don't report the percentiles. I think they would all just say 1 percentile. But if it's like 0.1 percentile or something like that, they probably still just write first percentile. I don't think they break it up further than that. So if you got like a 7 or an 8, it would probably also say first percentile. Okay, so the scores, like, they really aren't distributed like you would think they are. You really have to pay attention to the percentiles more than the number necessarily. Okay. So with the ACT or with the SAT, it's pretty much the same thing except for there's more numbers. There's not just the 36 here. They have more, so they can divide it up a little bit more. I'm not as familiar with those scores, but I would think there's pretty much like a 1-to-1 translation between the ACT and SAT scores. Like you can take your score in the ACT and convert it to an SAT score, and it converts pretty nicely. So you really only need to understand one of them. But this isn't the only example of percentiles. This is just this is one that most people encounter, right? Because everybody usually takes one of the standardized tests in high school. So you get these scores. Maybe you didn't pay attention to these scores, the percentiles. Maybe you only paid attention to this score. And that's what most colleges do, right? Most colleges just look at your score over here. They're not really paying attention to these. Now, it's important to keep in mind that this only applies to the overall score. When you talk about the individual scores, they can be very different. For example, if you get an 11 in English, that is the 10th percentile. Okay, so an 11 in English means you did better than 10% of people. Much different than the 1% of people here. So a lot of them are, all of the 4 subjects all have different percentiles based on the scores. This is for the overall score. All right, so let's forget about the standardized tests now. So these are the percentiles. What we're often interested in is what's called a quartile. Okay. So a quartile, well, let's think about that. 4 typically means 4, right? You think like quarter, that means you're dividing something into fourths. So a quartile are 4 special percentiles: the 25th percentile, the 50th percentile, 75th, and the 100th percentile. Okay. So a quartile is a special percentile. Okay. The first quartile, which we typically will call Q1. Let me get rid of this. Is the 25th percentile. Okay. Etc. And I'll make a little table here in a second. But so if we talk about the first quartile, all we mean is the 25th percentile. Okay. So we can make a table here of the quartile, the notation, and the percentile. Okay. So Q1, or I'm sorry, the first quartile is Q1, and that's the 25th percentile. So just like quarters, right? The second quartile is Q2, that's the 50th percentile. The third quartile is Q3, and that's the 75th percentile. And the fourth quartile, that's Q4, and it's the 100th percentile. Okay. So Q2 is one we typically would be interested in a lot because that says 50% of people did at or below this. And on the flip side, that means 50% of people did better than this. So it's like the halfway point in a way, right? It's what we would call it's, well, we'll talk about it in a minute. Okay, so typically we'll just, instead of writing first, second, or third quartile or fourth quartile, we'll just write Q1, Q2, Q3, or Q4. And that translates into one of these special percentiles. So if we look back at the ACT scores, we don't have them exact again, but 20 is about the second quartile. So that's about the halfway point where half the people did worse than this, half the people did better than this. 24 is about the third quartile. Not exactly again, it's the 74th, but it's almost the third quartile. 36 is about the fourth quartile, and 16 is almost the first quartile. Okay. So let's talk about well, first of all, why would we use a percentile over just a percentage? So for example, with the ACT, if you get every single question right, why don't they tell you got 100%? Why do they tell you got a 36 instead? Or if you get a 50% on the exam, if you get half the questions right, why don't they just tell you got a 50% instead of giving you a number? Well, we typically want to use percentiles when we're trying to compare the data amongst each other, right? With the standardized test, we don't want to tell you how well you did on this test. We want to tell you how well you did on this test in comparison to everybody else. Meaning, where do you stand in comparison to everybody else, right? Where is your knowledge in this particular subject? Where exactly are you on it compared to other people? And for that reason, if you take the exam 2 different times, you might get 2 different scores, even if you do similarly, because it depends on how everybody else did too, right? If you are in the 50th percentile, they're telling you did better than 50% of people. But the first time you take it, that might be a different number than the second time you took it. The reason why the ACT and SAT and stuff like that works is because our sample sizes are so large, right? There's a lot of people taking the ACT or the SAT. So there's a large sample. So you usually do about the same, depending on no matter when you take it. Usually it might change by like 1 to maybe 2 points, but it's not going to change drastically. So they're usually used with very large populations like this. The ACT and the SAT are used for every high school junior and senior in the whole country. That's a very large population. So it's useful to use these percentiles so you can see where people lie in relation to each other. Okay, so I've said that the Q2 is the 50th percentile. That's about half of the people scored at or below this, half the people scored above this. So it's the halfway point. Another word we have for the halfway point is what's called the median. Okay, so this is the definition. The median is a number that measures the center of the data. Okay. So in 2.5, we're going to talk about measures of the center of the data in general, and we'll talk about the median again there. Notice it says a number. It's not the only number that can measure the center. We could also have the mean, like the average, which we talked about in chapter 1 very briefly, or the mode, which we'll talk about. But the median is a common number that measures the center of the data. This is the number that is the exact middle of the data. Okay, so it is the exact middle. So this is how it differs from the mean. Okay, this one gives the exact middle, and the mean, you add all the numbers up and then divide by however many there are. So sometimes these numbers will be the same, sometimes they won't. It depends on how your data is distributed. It also doesn't actually have to be one of the numbers in your data set. So let me give you an example here. Let's say that we have test scores. Okay. So test scores, and let's say that there's 0, 50, 75, 41, 80, 66, 1, 2, 3, 4, 5, 6, 89, 94, 53, 68. Okay. So let's say these are our test scores right here, and there's 10 of them. Okay. So we want to do a couple things. Let's find the median, let's find the mean, and let's also find the quartiles. How do we do all of this? Well, before we do anything, we should probably put the data in order. Okay, we don't need to do that for the mean, but we do need to do that for the median to find what the exact middle is, and for the quartiles. So let's write it in order. Okay, so we got 0, and you can just kind of cross them off as you go. Next lowest is 41. Next lowest is 50. Next is 53. Next is 66. Next is 68. 75. 80. 89. 94. Okay. Make sure we count them all. Make sure we have the same amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now that they're in order, we can find all of those things. The median is the exact middle. Now we have 10 numbers here, so we can't really have an exact middle, right? If we start, what we want to do is we want to start at the ends, so the 0 and the 94, and then count in one at a time, right? So you could just kind of use your fingers. We have 0, 94, 41, 89, 80, 50, 75, 53, 66, 68. So it's a tie between 66, 68. So when there's a tie between them, so if there was no tie, we would just take that number as it is. If there's a tie, when there's a tie, we want to take the mean of the two numbers. Okay, so the mean was what we talked about in chapter 1. This is where we add the numbers up and then divide by how many there are. Okay, so we do 66 plus 68 divided by 2 because there's 2 of them. And when we do this, we should get 67. Okay. So the 67 here is the median. Okay, so this is the exact middle number. So notice it's not actually one of our numbers. So the median doesn't have to be exactly one of our numbers. Okay. Now let's find the mean just to compare here. We're going to do some more comparing of the mean and median in 2.5, but just to get a little practice before then. We want to add all of the numbers up and then divide by however many there are. So I'm just going to do it in a calculator here. We're going to do 0 plus 41 plus 50 plus 53 plus 66 plus 68 plus 75 plus 80 plus 89 plus 94. So we get 616 when we do that. Now we want to divide by 10 because there's 10 numbers. And we get 61.6. So the mean is also not one of our numbers. And also notice it's very different from the median. Okay. So the reasons for that we'll talk about more in depth in 2.5. But it essentially just means that more of our data is concentrated towards the bottom. And the mean is affected more by that than the median is. So the mean is being dragged down by those lower numbers, whereas the median isn't so much. Okay. And for that reason, usually when I look at actual test scores and I want to know about how everybody did, I usually am looking at the median rather than the mean. Okay. So let's talk about quartiles now. Okay. By the way, the median is the second quartile, right? The second quartile is where 50% of the data lies below this. That's the exact same thing the median means, the exact middle. Okay, so the second quartile, Q2, well, let's write them in order. We'll find Q1, but Q2 is the median. Okay, so it's 67. So where's the first quartile? We want to know where's the point where 25% of our data is at or below this number. Okay. So we want to know about where 1/4 of the numbers are at or below this number. Okay. So let's think about how many numbers we have, right? We have 10 numbers. So if we wanted to do 25% of 10 numbers, that would be 2.5. So we have to find the part where 2.5 numbers are at or below this number. That doesn't really make much sense, right? But for 50%, so let's think about the second quartile and try to translate into the first quartile, right? For the second quartile, for 50%, we had a tie. We had the 5th number and the 6th number, right? And we found the average of those two in order to find exactly what it is. Okay, so the So like I was saying, the for the second quartile, we had a tie between the 5th and 6th number, right? And that essentially it told us that, let me use a different color here. This to the left of the red line here is the first half of the data, and to the right of this red line is the second half of the data. So if we want to divide it even further into further halves, well, the exact middle of, think about like 25% is half of 50, right? So this is where the 50th quartile is, and it divides it into our first half and our second half. If we want to find the 25th quartile, it's going to be half of the first half, right? So 25% is like half of a half. We could think of it in fractions, like 1/2 times 1/2 is 1/4. So if we want to find the first quartile, we want to find the exact middle point of the first half. So we essentially just look at the first half and we find the median again, which is the exact middle. So that's going to be the 50 here, right? So this is Q1. Similarly, for the third quartile, we're going to take the second half and look for the exact middle of that data set. Okay. 75% is exactly halfway between 50 and 100. So this is 50. This is going to be 100, right? The very end of our data set will be 100. So we are going to look for the middle number of this second half of the data. So that's going to be the 80 here, right? We don't have any ties in this case. So this is Q3. So Q1 is 50 and Q3 is 80. Okay. Q4 we don't typically write down because Q4 is just like the biggest number essentially, right? Q4 would just be the 94 here. It's going to be Q4 is the 100th percentile, so that's saying every number is at or below this number, so that's going to be whatever your last number is. So we don't typically write it down. Now, Q2 is very important because that's the halfway point. You know, naturally, we're going to want to know what that point is. When I'm looking for test scores, that's typically where I'm looking at. Q1 and Q3 are also very important, though, because they give us what's called the interquartile range. Okay. So let me write that down as a definition here. The interquartile range, or the IQR, is a number that indicates the spread of the middle half, or 50%, of the data. It is the difference. Let me write this in a different color. It is the difference between the third quartile. Actually, let me just write Q3 and Q1. Okay. So the interquartile range, it's the number that indicates the spread of the middle 50% of the data. Let's go back up here and look at what that means. The middle 50% of the data is this part right here. So from 50 to 80. Okay. Why do we care about this? Well, we would care about this because this is where typically, in this example, where people are typically scoring, right? This is where like the average person in the class is scoring. We want to know how big of a difference is there in this range. Okay. So here the interquartile range is the difference between Q3 and Q1. So that's 80 minus 50. Remember, difference means subtraction. Okay. Sorry. So we get 30. So there's about a 30-point spread in the middle here. The outside numbers are what we call outliers. Okay. Well, not exactly. I'll define them more precisely in a second, what an outlier is. But the idea is like typically we're most concerned about what happens between the 25% mark and the 75% mark. How are people doing in this range? Okay. So here there's a 30-point spread. So is that good or bad? I mean, it depends on your goals, but typically that is a pretty big spread. But maybe not so big. It's hard to say because there's only 10 people in this class, so we don't have a lot of data to work with in the first place, right? So let me write the definition down, or the formula down rather. The IQR, interquartile range, is equal to Q3 minus Q1. Okay. So we can use the IQR to look for what I was saying is called an outlier. Okay. So outliers they're kind of like numbers that break your trends. Okay. So most of your data is within this part, but then you have some few people on the outer extremes that really don't fit in with the rest of the data. So the outliers can be of particular interest because you want to know, well, what exactly did they do differently? Why did this person get a 0 on this test even though most people got between 50 and 80? Why did this person get 100 on this test even though most people got between 50 and 80? Well, with the 0, we could think, okay, maybe they just didn't show up for the test, right? So that's something that's particularly interesting to note because is it even really fair to count that in the rest of the data? Maybe they're very underprepared for the class, like they haven't taken their proper prereqs. They haven't shown up to class at all. Like maybe the test day was like the first day they showed up. With the 100%, maybe the class is too easy for them. Maybe they don't even need to be in this class. Maybe they just studied a lot and nobody else did, and that kind of dragged down the data. It's hard to say for sure, but these are the things we want to study, right? So we want to know what the outliers are. So an outlier is defined as, whoops. So a value is suspected to be a potential outlier if it is less than 1.5 times IQR below Q1 or more than 1.5 IQR above Q3. Okay. So are the if we go back and look at our data set up here, is the 94 an outlier? And is the 0 or 41 an outlier? Well, our IQR is 30, right? So 1.5 times the IQR is 1.5 times 30. You could just do this in a calculator if you wanted. It's 45. Okay. So for something to be a outlier on this side of the data, it would have to be 45 more than 80, which means it would have to be at 125. So that's not really possible because unless there's a lot of extra credit on the test, you can't get up to 125%. To be an outlier on this side, you would need to be 45 below 50. So you'd have to be at 5 or less. So we do have a 0 here. So this is an outlier. Okay. So it's the numbers that are very far away from the middle of the data. Okay. We expect most things to be around the middle of the data. But when things are really far away, we want to know why, right? What is causing this person to get a 0? That's so far away from everything that it's really skewing our data. It was really dragging the mean down, for example, compared to the median. It's 41 points away from the next number, whereas the gaps between these numbers are only 9, 3, 13, etc. They're not very large, but this one is a whole 41 points away. What is causing that? So we want to identify the outliers because we typically want to study them further. Or maybe we are maybe we don't want to study them further. Maybe we're looking at things that went wrong in the testing that caused these outliers and we just write them off as an anomaly, right? Either way, we need to identify what they are. So we want to do 1.5 times what the IQR is. So we find the IQR by doing Q3 minus Q1. First, we got to find those. Then we do 1.5 times that to find the outliers. Okay. All right. There's only a couple more things in this section. So I only did the one example here for the quartiles and the IQR and the outliers. So I definitely would encourage you to go through another example, and there will be some on the homework. Okay. We only really found the quartiles here. What if we want to know a specific percentile? Okay. Typically, the quartiles are the most useful because, we need to use them to find the outliers. But what about for finding just general percentiles? Let me try to change this here. So there's a lot of different formulas for this. There's not just one formula. Here's the formula that the book gives. Formula for finding the kth percentile. Okay. So first, let's define some variables. K is going to be the kth percentile. So if we're looking for the 40th percentile, for example, then K is going to be 40. Okay. I is going to be the index. Typically in math with I, we write the I with a little tail like on it, like this. Typed, maybe not so much, but in the actual math, when we're using it as a variable, it'll typically have the tail on it. So that's all that is. Equals the index, which is the ranking or position of the data value. So this means if you put them in order, what number is it? So up here, for example, for talking about the number 41, I would be 2 because it's the second value when we put it in order. Okay. N equals the total number of data. So how many numbers do we have, right? So in our test scores example, N would have been 10 because we had 10 numbers. So first we want to order the data from smallest to largest, if you haven't already. This is pretty much always step 1. We just want to order it from largest or smallest to largest. 2, we want to calculate I equals K over 100 times N plus 1. Okay. So let's think about the 40th percentile. Okay. So let's do an example. There's still 2 more steps, so I'm just kind of like going as an aside here. The 40th percentile. And we'll use our test scores examples. I'll scroll back up when we need to. I is going to be, well, K is 40, because we're talking about the 40th percentile, divided by 100 times 10 plus 1, because our N was 10. So this is 0.4 times 11, which is going to be 0.44. Okay. Wait, no, sorry, 4.4. Right. Yep. So our I is 4.4. Okay, what does that mean? Well, I is the index, but what's the 4.4th number? Well, steps 3 and 4 give us instructions for this. If I is an integer, okay, integer is like a counting number. So like 0, 1, 2, 3, 4, 5, or -1, -2, -3, -4. So not this number. So we're not going to use this step. But if I is an integer, then the kth percentile is the data value in the ith position. Okay. So like if I was just 4, for example, we would just go find the 4th number, and that's your 40th percentile. Ours is not an integer. We got 4.4. So what do we do with that? If I is not an integer, then round I up and round I down to the nearest integers. Okay. So if we rounded 4.4 up, we would be at 5. If we round 4.4 down, we'd be at 4. And then average the 2 data values in these 2 positions. Okay. So like I said, if we take 4.4 and we round it up, we'd be at 5. If we take 4.4 and we round it down, we'd be at 4. So we want to take the fourth number in our data set and the fifth number in our data set and take the average of those two. Let's go back up to our data set. The fourth number is 1, 2, 3, 4, 53, and the fifth number is 66. Okay. So we're getting pretty messy over here. 53, 66. So we want to take the average of these two numbers. Okay. Let's just go back down here. 53 plus 56, or 66, sorry, divided by 2, because we're taking the average and there's two of them. Okay. So 53 plus 66 is 119. Divide that by 2, and we get 59.5. Okay. So 59.5 is the 40th percentile in our example. So that means 40% of people got a 59.5% or worse. Okay. So to recap, first we order it, then we calculate I with this formula. So this is K is the percentile, N is the amount of data that you have. We had 10. Then depending on what I is, if I is an integer, you follow step 3. If I is a not, you follow step 4. Now, we could have done this for Q1, Q2, and Q3, right? We could have just calculated the 25th percentile, 50th percentile, and the 75th percentile, and it would give us the exact same number. We just had easier ways to do that just by counting the numbers that were involved. So we didn't have to. So the next thing it goes through is talking about a formula for finding the percentile of a value in a data set. So this is a little different. It's saying, okay, what if we have the number 53? What percentile is it? So it's asking the other question. It really just boils down to doing this backwards. So I won't really go through that, but I would encourage you to take a look at it if you are interested in it. We typically won't be asking that question though, so it's not as big of a deal. But again, you can really find it from what we did here. So it's not too important to go over by itself. So for this section, I'm going to leave this here. So just as like a recap of everything we did here, we talked about percentiles and what they are, special percentiles called quartiles, what the median is, how to find the 3 quartiles, and then how to find the outliers, and then finally how to find percentiles. Okay. So these will be on the next homework. There will be lots of practice with this. So yeah, if you guys have any questions, please let me know. We'll do 2.5 at least in the next video, and then we'll go from there. 2.5, we're going to talk about averages more generally, so the median and the mean. We're going to go more in depth with those and the difference and when we would use each one. Okay. So thanks for watching today, and I'll see you on the next one.